Hello everyone, my name is William Keung. I'm a senior software engineer in adMarketplace for a little bit over a year. We're going to talk about, we're going to do a pre-presentation before our main focus over here is Ben. So the pre-presentation is all about how we develop an abstraction layer for our NoSQL implementation. So give you next slide. So here's the agenda. Give you an overview of who we are, our environment, bottom up, some of the driving forces, why we made an endeavor to actually go about designing a data abstraction layer for a lot of our NoSQL technologies, and then some of the challenges we've gone through, real life experiences from our side. After going through real life experiences, we can give you a couple of scenarios, some basic ones that we've encountered, fairly common on our side. And after that, we'll talk about a little bit about the design itself, what to consider as part of your design, and some testing methodologies we went through. So let's get started. So who are we? We are adMarketplace. We are the leading search syndication. We are the biggest search engine outside of Yahoo, Bing / Google. We have about 250 major advertisers, clients, and about 100 million user profiles we have. So our systems are pretty high, very highly available. Sorry. 24/7. Our number of requests we go through is 10,000 requests per second. Usually our search response time is less than 10 milliseconds. So some of the NoSQL implementation we've done at the moment, it contains about 100 gigabytes of data. And then we always have to maintain a high availability. So in other words, if something goes down, our recovery rate has to be pretty fast and pretty, quick. So just to give you an idea, so pretty straightforward. We got the feed server sending out the ads. It's connected to various NoSQL technologies involved. We have our traditional databases, and we have the click tracker to keep track of all the clicks that's coming in. So next slide. So some of our driving forces. We wanted basically easier migrations. We know we're going to go through several iterations of evaluating NoSQL technologies. What's a better way to do it is to provide an abstraction layer. So you definitely want to, it gives us at least it gives us the ability to swap out implementations. Now we've gone through a few. The legacy stuff, when I say legacy, is usually just a straight direct connectivity to Memcache. We also have developed other technologies leveraging SPI Memcache and of course Aerospike. So it allows us to flip implementations fairly easily. So for the next one, why do a driver abstraction? We want to definitely decouple roles of responsibilities here. This is straightforward. This is fairly straightforward. You want to abstract most of your low-level data sources and the intricacies behind it versus, from the actual business object itself. This actually, it's increased developer productivity. It's faster development cycle. You don't want your developers to think about how to connect the plumbing and connecting to a NoSQL resource. You want to take care usually the connectivity, the plumbing, any little intricacies, retries, timeouts, all that little stuff. You want to take care at a low level, the driver and our data access layer. Let the developers working on the business object themselves. For the next part, now I don't know how familiar you're with Memcache. It's a pure caching technology. The thing crashes, and obviously everything goes away. So when we wanted more persistence. This is going to help us in the long run in terms of recovering from a crash itself. Right now, if one of our Memcaches, if one of our Memcache crashes, what would happen is like we would probably have like some type of independent process that would go about updating the indexes and the data key value sets for our feed server to go through. Performance and scalability. When we're evaluating like NoSQL implementations, we've come to the conclusion certain technologies wouldn't work well in certain scenarios. And that's, we had a case where we were leveraging, we were trying to use MongoDB, for example. We loved the fact that it was, you know, it was object oriented. It was like more of a document type of like data storage you're putting in there. Unfortunately, for certain scenarios, it would not allow us to scale the way we want it to be. So after going through some evaluations, we flipped implementation in certain instances, and it worked pretty well for us. And transparency. You have an implementation accessing data, you're accessing a particular data resource. Usually the problem is like when you get a production issue, you want to figure out what was the query being ran, you know, what was ran, you know, how long it took, and so forth. You want that information. So for us, it was a big plus for us, especially when we're going through 5,000 to 10,000 ads per second. It allows us to view what data is in production at the moment, at this particular time. I'll give you a quick example of that one. Straightforward. So some of the challenges that we've encountered, we have systems, multiple systems that share the NoSQL databases, resources, and that becomes problematic, especially with the Java object serialization. Another point to consider when you're designing a data access layer, or maybe is how you perform key generations. If you're doing Memcache with pure key value pairs, think about what are you going to do for key generation of one technology versus another. And on top of that, how are you going to do a search versus one technology over the other? So you don't want to keep that abstracted from the actual developer. Legacy maintenance. You know, breaking up is hard to do. You want to leave certain technologies. The problem is it's hard to do it. So how do you become backward compatible? And you know, in addition, we also have to support hybrid technologies. We're using MongoDB. We're using Memcache, Spy Memcache, and Aerospike. Code upgrades is always going to be difficult. We can't fully shut down a system because it's always constantly 24/7 up just to perform an upgrade. It's not cost feasible for us. And we've also encountered a problem with testing. A lot of data we collect, it becomes stale. It's hard to test with it. So we'll go through some of these challenges, how we sort of went around. Let's talk about scenarios. Two different systems sharing a NoSQL resource. So here, we use this, we use this just to feed some of the click data over to Memcache, and click tracker picks up that data. We use a hybrid technologies over there. It's a various of Aerospike, Memcache, and MongoDB. This is probably one of our most challenging things to replace, to transition during a migration, just because it's like the best analogy I heard was probably from Mike, my manager. It's like swapping out wheels while you're still driving. You know, it's kind of hard to do that. It's very difficult. So a lot of the phases that we've gone through was we created an abstraction layer. We still maintain the connection to legacy systems, and we start slowly moving away from a legacy driver to a more updated or even a new implementation of a driver. Second scenario, we have an independent process updating large amount of data sets into a NoSQL database, and our feed server just picks up that data. And here it's a lot simpler than before because the independent process runs usually agnostic of the systems out there. So it just continue to just updates data in a periodic level. So think of it as typical batch cron job going off. In this case, we can actually shut down the system and make updates on both sides. We can upgrade the feed server on one side, and then we can independently afterwards upgrade the independent process. So third scenario, the easiest option. We have your data, you have the DAL. Right now, I'm using Aerospike. And that abstracts the implementation of how we connect to Aerospike and so forth. So this contains, for us, it contains several days of activity, user activity. And that could range from 5 gigabytes to 10 gigabytes of data. A lot of data. Basically, we track user profile, user activity with this. And yes, and that's pretty, one of the requirements we need was that it needs to perform like 5 milliseconds, going in and out. 5 milliseconds in, 5 milliseconds come back. Actually, it does pretty well. We get, I think, what's that, 1 millisecond return response rate?
It's
average.
1 millisecond.
Yeah.
99%.
Yeah.
It's really fast.
It's really fast. And yes, this is the easiest to replace. So if you are going to go on an effort to actually design a data access layer and provide this to your developers and your business, your core business developers, things that you want to look out for, and something that we have to consider. If you could find a way to abstract key generations, like sometimes it could be hash, or it can even be a simple string concatenation, whatever it may be, abstract that from the developers. You don't want developers to figure out what's going to be the expected key in that NoSQL resource. Don't have them think about that. Provide an API that will be able to say, hey, with this particular ID, we'll be able to get this particular value. Sometimes you will definitely want to provide factories or build type of patterns for your developers. In some instances, we wanted a singleton. And some instances, you want a factory, whatever it may be. It could be a flyway, combination of the two. So this way, you abstract a lot of complexity in building a connection object. Search query. Sometimes search query can be complicated. Abstract it if you can. And error and exception management. Certain exceptions you can handle on your own. Certain exceptions, leave it to the developer. It's pretty straightforward. But properties we need to consider when developing drivers. Data access, abstract data access there. One is thread safety. What if the vendor gives you a driver that's not thread safe? You're going to have to make it thread safe. Connection timeouts. For us, is as we need to be very keen about this. We are about fail fast. If we're going to fail fast. We don't want a particular thread to hold up a resource, waiting for a response coming back. If it doesn't come back in 2-3 milliseconds, boom, just drop it. Just move on to the next request. Read timeouts. So again, same mindset. If I can't be able to make a read, get a response from that particular resource, just drop the matter, just move on. And you may want to consider for failover. If one particular server is not responding, jump to the next one. So again, pretty straightforward. Maybe sometimes hopefully it'll help you out later on in terms of design. There you go. So let's talk about a little bit about testing methodology. When we were executing this migration efforts, the first thing we did was a lot of unit testing, a lot of integration testing. And I'm talking about, two things that came really pretty handy was, if you're able to do mock testing. I use Mockito. Have you guys ever used that technology before? It's great technology. If you need mock behavior, mock data, it's just wonderful technology. Overriding privates. I don't know if you're aware of this, but you can take an object in runtime, tell it, override the private behavior, test it internally, make sure the state of the object itself is what you expect. Once you verify that definitely helps you along the way. During this whole process of implementing a data access layer and testing, we pushed in a lot of logging, a lot of comprehensive logging. You don't want to know how much log statements, before and after statements, unbelievable. And during this whole process, we also picked up other things. Like, for example, we learned to record pure HTTP requests. Now, I know we mentioned there's a lot of the data set that comes in becomes stale, but there's still some value in terms of recording that live data. So I know we can't replicate the stuff. We can't replicate the data back in the database level, but we can at least simulate traffic and understand, like, no logic bombs at least, you know. So that helped us out a lot. And for us, we use statistics as metrics when we push into production. We push the code set into one server, let live feeds come in, and once they come in, we measure, like, how many clicks are being tracked, how many queries are running in through that server. If it matches to the other servers, what is our conversion rate? You know, all these metrics do matter. You know, talk to your business folks. They should have that information. So here, I know we talked a little about transparency. So a lot during this whole driver implementation, data access implementation, we've actually made, you know, headway in terms of exposing and improving our transparency. Because in production, when this goes in, usually you can't really use logging to track down a defect. So there are certain types of things I want to get. Statistics are from Memcache. I want to know how many hits are being get, any false hits, any evictions. You know, I want to know that rate. So that definitely helps you out in terms of understanding how well you're doing this whole migration effort. So yeah, we basically expose these properties via JMX beans. And, you know, the JMX beans, they provide us the data driver, and in conjunction with JMX, provide us a way to abstract not just the data layer, but also the business side. We have a process of blacklisting IP addresses from detecting fraud. Now we have dynamic IP addresses we have to detect for. We also have, like, permanent IP addresses. So you want to hide that information. I mean, I blacked out some of the important ones, but anyways, you pop an IP address. I don't want to know how you want to go about. I'm telling the system, I don't want to know how you go about to find out if this IP address is blacklisted or not. Just go find it for me. And that's pretty much it, guys.